My name is Liad. Today I will discuss a data structure called prefix sum. This is a range query data structure. You can call it as a technique also. Suppose you are given an array of n integers and you are also given q queries. In each query you have to find the sum of all the elements in range L to R. Suppose this is the array. This is the array you are given and you have to find the sum of all the elements in some range from L to R. Suppose this is L equals to 2 and then R equals 5. So if you have to find the sum from 2 to 5. Okay, so in naive approach what you can do, you can move from 2 to 5 and in every move you can keep adding the value into a sum variable, right? You will move from 2 and you will add 10 into a sum variable, then you will move 3, you will again add 8 into some variable, then you will move this index and you will add 2, then you will move this and add 7, right? So in this way you can get all the sum in this range, right? But you can't do in this way because there is a problem, because in problems the size of the array, which is n, should be in range from 1 to 10 to the power 6. Okay, and the number of queries also should be in the range 1 to 10 to the power 6, and LRR should be inside the 1 to n. So if you do in this way, so in worst case you are traversing all the size of the array, which is n, and you are doing this in all the q queries, right? Suppose in some query you are given 1 to n by 2, and in another query you are given n by 2 plus 1 to n, then again 2 to n by 2, in this way. So in worst case traverse you will traverse the size of the array, which is n. You will do order of n operation in every query. So in q query the operations will be n into q, right? So the time complexity will be n into q. So it is 10 to the power 6 into 10 to the power 6. This will be huge, right? So you will get TL. So then what will be the optimization? How can we do better? Suppose this is the array and we have to find the sum from 3 to 6. This is 3 and this is 6. Okay, so you have to find the sum in these range. So what we can do is that firstly we will find the sum, or we will find the sum in from this range 1 to R. Okay, we will add the all the elements from 1 to R in our sum variable, and then from this we will subtract from 1 to L minus 1, sum of all the elements of this we will subtract from the sum variable. Okay, then we will get this sum, right? L to R. Okay, suppose this range sum is B and this range sum is A, so we have to find B, right? So for this we will add all the elements, so this will be A plus B, right? So this is A plus B, and from this we are subtracting these range elements, so this is A, right? So A minus A will be cancelled out and B will be the remaining. So this will exactly we are finding. So in this way you can do, but in this way we are also doing order of n operations, right? We are finding the sum from 1 to R, then again on to L minus 1, then we are subtracting. So if we do this in every query, then also this will give me TLE, right? So we will not do it in every query, we will do some pre-processing. So this is the intuition behind the prefix sum. We will do pre-processing in the prefix sum data structure. So what will be the pre-processing? In the prefix sum data structure, suppose in the index x of prefix sum data structure, we will store the sum from 1 to x. Okay, in index x we will store the sum from 1 to x. So we will do in pre-processing. So how can we do? We will move from 1 to n. So and we will keep adding all the elements of the array. Okay, so the first index, the first element of the prefix sum will be as the same of the array, because there is no element before this, right? So on to 1, from 1 to 1 the sum will be the element of the array in the index 1, right? So then we'll move to index 2. Then we will add the element of I minus nth index, which is the previous index of prefix sum. We will add it to the current index of array. Okay, this is 4 plus 10. We will store this inside the current index of prefix sum. Then again we will move to the next index. Then we will do the same thing. You will add the previous index prefix sum to the current index of the array. Okay, this is 14 plus 8, which is 22. So in this way we will make the prefix sum data structure. So this is the implementation. Firstly, I have declared the prefix sum. The size will be the same of the array. The zeroth index will be 0. Prefix sum of 0 will be 0, and we are doing on based indexing. So if we don't do this 0, we have to make some condition also, because we are accessing the I minus nth index also, right? So to make our life easier, we are initializing the 0th index to be 0. Okay, then I am traversing a loop from 1 to n. In every step we are doing prefix sum of I equals prefix sum of I minus 1 plus array of I. So in the ith index of prefix sum we are storing the addition or summation of the element of I minus nth index of prefix sum and the element of ith index of array. Okay, we will do this in pre-processing, right? Then in every query we will return or print this sum. Okay, so sum will be, suppose we have to print the sum from range L to R. We will firstly do the sum from 1 to R. This is inside the index of prefix sum of R, right? Then from this we will subtracting the sum from 1 to L minus 1. So this is inside the index of L minus 1 of prefix sum, right? This will do in constant time in every query. So we are doing simply order of n plus q time complexity in this way, right? So it will not give TLE. So what are the operations we can do in this way by this prefix sum data structure? It depends on the property of operations. So the property will be invertible. That means a dot a should be 0. So dot is here operations, any kind of operations. So what are the operations? Suppose addition is a operation which is invertible, because we know that the inverse of addition is subtraction, right? So a minus a will be 0. Then we can do also XOR in this way. A XOR a equals 0. If you don't know about XOR, I have a playlist of bit manipulation. Inside this playlist I have already made a video of bitwise operators. I have talked about all the bitwise operators and their operations in that video. So firstly see that video. So what XOR does is that if we do XOR two values, then the corresponding bit of two values of or two elements, the corresponding bits of two elements, if the corresponding bits are same, then it gives 0, otherwise it gives 1. Okay, so here a XOR a means two values are same, so the bits, all the bits of two elements of these two elements will be same, right? So all the bits will give 0, so the result will be 0 also. So let's see the XOR operations using prefix sum. Suppose this range to this range, XOR of all the elements of this range is B and XOR of all the elements of this range is A. Okay, we have to find the XOR of all the elements, so we have to find B, right? So what we will do in prefix sum data structure, we will do XOR of all the elements from 1 to R, right? This is 1 to R, which will be A XOR B, right? Which will be A XOR B. Then we in with this we will do XOR from 1 to L minus 1, right? So this is A. So this is A, and so overall XOR will be A XOR B XOR A, right? So that can be written in this way: A XOR A XOR B. A XOR A should be 0 and B. So 0 XOR B is equals B, right? So this is the result. we can see. So we can do the XOR operations in this way. But suppose if we have some operations like that is not invertible, we have to find the maximum elements in this range. Can we do it in this way? No, right? Because if we do it in this way, what will be the approach? The we will find the maximum elements from 1 to r. So this is 10, and then we will find the maximum of 1 to l minus 1, right? So this is also 10. So the maximum in range 1 to r is 10, and the maximum of range 1 to l minus 1 is also 10. So this is 10 and this is 10. So what will be the maximum of this range? We don't know, right? So we can't do this in this way. So what will be the approach then? How can we do it? We will see that in the next video. If we want to see that, please stick with me. So this was all for today. Till the next video drops, keep practicing. Thank you for watching.